In today's lesson, I'm going to introduce you to what is called a logarithm in math. If you've ever seen a button on your calculator called log, you may wonder exactly what that is. And hey, you're going to learn all about it here in today's lesson. Before I can really explain to you what a logarithm is, I really want to talk about opposites, okay? Everybody knows what an opposite is, okay? Let's look at this first function that's written down here. Y equals 4 times x. Now you start asking the question, you start asking, hey, what's the opposite of multiplying a number by 4? And I think everybody knows that. The opposite of multiplying by 4 would be dividing by 4. So here, if I were to write this opposite function over here, x divided by 4, well, in algebra, we call these two functions that are opposites, we call them inverses. And here is proof that two functions are inverses. Let's use like the number 3. If I were to plug in a 3 into the first function, I would get a value of 12. 4 times 3 is 12. But then if I were to plug the 12 into the second function and take 12 divided by 4, it would return a value of 3. And this is proof that these two functions are inverses. In the first function, when I input a 3, I get an output of 12. But in the second function, when I input a 12, I get an output of 3. That is proof that these two functions are called inverses, which means that they're the opposites of each other. All right, let's talk about what's the opposite of squaring something. And hopefully a lot of you know this opposite. The opposite of squaring something is square rooting something. And so these functions are called inverses. And here's proof. Let's use the number 3 again. If I take 3 and square it, I get an output of 9. Okay? But then in the second function, if I were to input a 9 into this second function, I would get an output of 3. So here I have an input of 3 and an output of 9. Here I have an input of 9 and an output of 3. These are called inverse functions. Okay, so hopefully these opposites I'm sure are familiar to you. The opposite of multiplying by 4 is dividing by 4. The opposite of squaring something is square rooting something. But what about this one? What's the opposite of taking something to the x power? Okay, generally the opposite of an exponent is a root. So in essence, sometimes you might think, well, is there like an xth root? Can I write something like the xth root of 10? Okay, and here's what we do, okay? There's no like xth root. That doesn't exist. What we use instead is what's called a logarithm. The opposite of taking something to the x power is taking its logarithm. And so the opposite of 10 to the x power is the log of x. So once again, let's use 3 as an example. Here's what this means. If I plug a 3 into this first function and do 10 to the third power, 10 times 10 times 10, it comes out to 1,000. So what does that mean? This means if I take the log of 1,000, it comes out to 3. Okay, let me grab my calculator. Just in case you don't believe me, here we go. The log of 1,000 is 3. Okay, then let's do it with like one more number. Let's pick like a 5. Okay, if I took 10 to the 5th power, 10 multiplied by itself 5 times, it comes out to 100,000. Okay, what that means then is that the opposite of that, if I take the log of 100,000, it should come out to 5. Let's check it out. Log of 100,000, it does. It comes out to 5. So log is a way to take the opposite of an exponential function. The opposite of taking 10 to the x power is taking the log of x. And I know that's a weird concept. Sometimes it takes me a while to wrap my brain around this. But this is what's going on with logarithm. Okay, now the actual definition is a little bit fancier than that. I'll explain here in a little bit. Here's the definition I want everybody to write down. Let me write it down first. Okay, make sure you write this definition down. It will come up again and again. This is pronounced log base b, that's a b right there. Log base b of n is equal to p if b to the p power equals n. Now you're already familiar with this form right here. This is called exponential form. This is the form you've been using since, I don't know when you learned exponents, middle school, 9th grade, who knows? I don't know for sure. But you've known exponential form forever. This form over here, though, it's a different way of saying the exact same thing. This over here is called logarithmic form. Okay? But this is how the definition goes. Now, there's a couple of conditions I want to write down real quick. This only works, b and n have to be positive for this to work. You can't define this if b and n are 0 or negative. And also b is not allowed to equal 1 for this to work. Okay, so let's put this into practice. I think this definition makes a lot more sense if you look at actual examples. Okay. So here is a true statement. 6 squared equals 36. Does anybody want to argue that, right? That's true. You want to try to argue that. Everybody knows 6 times 6 equals 36. So this right now is currently written in exponential form. This is familiar to you. You've seen this many times, okay? You know what exponential form is. We need to write it in log form. Well, the fancy way to do it is we identify here. We say that the 6 is called b, like my definition here. That's the base number. The 2 is called p. That's my power, second power. And the answer, the 36, is called n. All right, so if I rewrite that in my new form, I'm going to write log base 6 of n of 36 is equal to p. Here's how I would rewrite that statement in a different order, in a different form. Just like this is a true statement that we know is true, 6 squared equals 36, so too is this a true statement. Log base 6 of 36 equals 2. Okay, now let's go in the opposite direction. Here it says write this in exponential form. So we could say the base number b is 25. This 5 here is called n. N is 5. The answer here, or I'm sorry, the p value is 1/2. All right, so if we rewrite this in exponential form, it's the base number 25 to the p power, 1/2 power, is equal to this answer, 5. These are both true statements, and they're both stating the exact same fact. Now, real quick with both of these, I'm going to show you kind of the shortcut I do in my head for this. Pretend like you didn't know this answer. Kind of play dumb for a little bit. Pretend like you don't know this answer. What I always do in my head, when I'm switching from exponential form to logarithmic form, I always remember that the b, you always keep the b in the front. This 6 is the b, the base number. It's going to stay first. It's just here, it's going to be written as a subscript. It's going to be written below the g. But I keep the b in the front, and then I actually flip the positions of the p and the n. The n and the p get flipped. The 36 is going to move to the left of the equal sign, and the 2, the second power, is going to move to the right. And I even have a little saying for this. I say keep the b, as in keep the b first, but then flip the n and the p. Keep the b, flip the n and the p. So, okay, so it works here as well. Here, I keep the base number first, but then I flip the positioning around the equal sign of the n and the p. The p gets moved to the left of the equal sign here, and this n gets moved to the right. Let's write this down. Those of you that like silly little rhymes to help you remember things, here you go. Keep the b, flip the n and the p. And this is almost like, I don't know if you've ever rewritten a sentence. I don't know if your English teacher's ever had you rewrite a sentence before. This is kind of like just like rewriting a true statement. You know, in English class, let's say you could word a statement. You could say, Tom gave Joe $5. Or you could flip it around and say, Joe was given $5 by Tom. Well, those sentences mean the same thing. They're just written in a different order. That's exactly what's going on here. These mean the same thing. They're just written in a different order. All right, on to the next examples. Okay, so here I have to evaluate the following. Log base 4 of 64 equals question mark. What does it equal? Well, I know what a lot of you are going to want to do right off the bat. A lot of you are going to want to grab your calculator and start using the log button. But here's the problem, okay? There's a major problem with that. Okay, you need to realize the log button on your calculator has a severe limitation. The log button on your calculator only does log base 10 of a number. Okay? So if you ever have a log base 10, then you could use your calculator, but this is a log base 4. And your calculator doesn't do log base 4. So anytime you see log without, notice there's no little base number written here. There's no way to put in a little 4 right here. Anytime you see a log without a base number written, it's an invisible 10 that goes there. So in other words, your calculator is not going to really help you with this. What we're going to do is we're going to rewrite this sentence. I'm going to call the 4 as my b value. I'm going to rewrite this. I'm going to keep the b first, the 4, and I'm going to kind of flip the positions of the n and the p. My question mark is going to go left of the equal sign, and my 64 is going to go to the right. You're only really, at this point in the chapter, your only really option to get this answer is to start guessing and checking. 4 to the first power is 4. 4 to the second power is 16. 4 to the third power is 64. So since 4 to the third power is 64, my answer is 3. Log base 4 of 64 is equal to 3. Okay, so let's do this again. I'm going to set this up. I'm going to say this equals question mark. Log base 5 of 1 over 125 is equal to question mark. Well, if I rewrite it, I think it helps it puts me in a position where I can kind of try to guess and check the answer. 5 to the blank power equals 1 over 125. Now this one has a little trick to it. You'll notice if I do 5 to the first power, it's 5. 5 to the second is 25. 5 to the third power is 125. Now this is interesting. 5 to the third power is 125. I need this to be 5 to the blank power equals 1 over 125. Well, what we're going to do, we're going to actually use a negative exponent. Here's what happens. If you use a negative exponent, like 5 to the negative third power, and now I'm going to convert this into a fraction, you get 1 over 125. Okay, the answer is negative 3. Because what a negative sign does is it takes your answer and it turns it into its reciprocal. Since 5 to the third is 125, that means 5 to the negative third is 1 over 125. This is what a negative power does, is it takes your original answer and it flips it into its reciprocal. So that's how I was able to note this is 5 to the negative third. All right, we got one more. So here I have 16 to the question mark power is equal to 4. And I have to try to guess and check this answer. Okay, so you'll notice on this one, that the number actually gets smaller. See, if I try doing like 16 to the first, if I try guessing and checking, 16 to the first, 16 to the second, 16 to the third, these answers are going to just keep getting larger and larger and larger. If I need my answer to shrink into a smaller integer, what I'm going to do is I'm going to actually start using fractions. I'm going to start using like 1/2. And 1/2 actually did it. I'm going to start using like 1/2, 1/3, 1/4. Here, the 1/2 is actually what did it. Gave me an answer of 4. Now here's the reason why. If you want an explanation on this, if you're like, Mr. Klein, explain that to me. The square root of 16 is equal to 4. And think about trying to write this as an exponent. With the square root of 16, remember square roots have an invisible 2 right here. And in the 16, you could say it has an invisible 1 right here. And remember what we learned in earlier chapters about writing this as an exponent. The square root of 16 to the first power, this number becomes the numerator of your fraction, and this number becomes the denominator of your fraction. So another way to write the square root of a number is to write that number to the 1/2 power. Okay, so that's why this works. This is the same as saying the square root of 16 is 4. All right, last example before we call it a day. Solve for x. Log of x plus 12 equals 200. Right off the bat, you're going to notice there's no base number here. This is just log of x. So I'm going to put, remember, if there's no base number, you have to put in a 10 there. You have to put in a base number of 10. So first thing we're going to do, we're going to subtract 12 from both sides in this problem. Okay, I'm going to write log base 10 of x is equal to 200 minus 12 is 188. All right, and then we're going to rewrite this. I'm going to keep my b at the front, but then I'm going to flip the positions of my 188 and my x. Oh, and holy cow, this is going to be a really large number. Okay, this number is actually going to be so large. The calculator is going to give this to me in, oh boy, it's going to give it to me in scientific notes. Okay, it's actually too large for the calculator to answer. Man, this is actually a 1 with 188 zeros after it. It's this enormous number, larger than a billion, larger than a zillion, just this enormous number. You know what? We're just going to leave our answer like this. This is in scientific notation. This is how you write a 1 with 188 zeros after it. Gracious, that was a large answer. All right, so those are your notes. Use these notes to help you on your assignment. Best of luck. Take care.